I'm going to explain how to make shapes using the dot product in Affinity Photo's procedural texture filter. I've seen a number of examples where people are using the dot product to create a shape like a hexagon or some other shape, and I've done it myself without really understanding how it worked. And so I thought I should try to look at the math behind it and try to understand how the dot product works and how it's used to make different shapes. And it turns out it can be a pretty flexible tool for making different shapes. But first I have to know what is the dot product and how does it work. The dot product between two vectors is defined as the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between the two vectors. The dot product takes two vector values and returns a scalar value. Scalar is just a way of saying that it's not a vector. The cosine of 0 degrees is 1, and so if the two vectors are pointing in exactly the same direction, it will have the highest possible value, and then it'll fall off as the vectors are pointing in different directions. The magnitude of a vector is defined as the square root of the components of the vector squared. So if it's a two-element vector of x and y, it would be the square root of x squared plus y squared. And that's also the length of the vector. But knowing the definition doesn't really tell me much about how I can make a shape with this. So I'm going to go and use Affinity Photo to mess around with it a little bit and see if I can make some shapes using the dot product. I'm going to start with a new document. I'll set it to XGA, but I'll set it to 1024 by 1024 pixels and make sure it's in RGB color mode. I'm going to fill it with black. And I'm going to add a live procedural texture filter. I'm going to start with a single equation and I'll assign it to all three channels. I'll add a real number input A, and I'm going to call that scale. I'll just set that to 1. And I'm going to use two -1 to 1 range inputs for my vector. I'll label those x1 and y1. And I'll just call this one x and this one y. I'm going to set those both up to 1. Now, usually with the dot product, I see it as a coordinate system and a vector. And so I'm going to set up a coordinate system, and then I'm going to use my custom inputs x1 and y1 to create the vector. So I'll start with the coordinate system v equals vec2 of rx and ry, and then times a and divide by w. That looks like that. Now when I'm working with geometry, in order to think about it better, I like to have the y-axis pointing up. And so to invert the y-axis, I'm just going to put a negative sign in front of it. And that will have the y-axis pointing up like that. I'm going to create a variable, I'll call it v1. And that will be a vec2 of x1 and y1. If I look at the length of v, that is starting at 0 and then increasing in all directions away from the origin. If I look at the length of v1, it's just a constant value, and I can calculate that since these are both 1, it is the square root of 2. So if I look at the dot product of v and v1, I get this. So when the coordinate system is aligned with this vector, which is the 1, 1 vector going off at a 45-degree angle, that will be at its maximum. And then it decreases as you move away from that position. Over here, there are negative numbers because the cosine is negative in that area. So I could bring that up. If I just invert this, I could see those negative numbers over here. So yep, there they are. As I move the x component towards 0, I can get a horizontal line, and then I can move it over here and have an angle of 135 degrees. And then back up to 45 degrees. Or I can move the y over to 0 and this one. And then if I move the x component, I can get any possible angle by manipulating these two components of the vector. However, one thing is happening. If I change these, I put them both down here, they're still at a 45-degree angle, but the range of my grayscale is different now. So if I wanted them, just to get the angle of these and to sort of ignore the magnitude of the vector, I could convert this v1 to a unit vector by normalizing it. So if I use the norm function on this, it then becomes a unit vector. So no matter where I have these positioned, it'll always have the same range across there. And that's going to be useful when making shapes. I want to make a shape out of this, and so I'm going to set that to be a variable d1 equals that. If I want to have a solid shape, I'm going to use a smoothstep function, and I'm going to make it a white shape on a black background, and to do that I need to use a smoothstepn function. And I'll use e and e plus s divided by 10, and then my d1 value as the inputs to the smooth step. So I need to add a 0 to 1 slider for e and another one for s. This is e, this is s, this I'll label the edge, and this I'll label smooth. And I'm going to bring the edge down to 0 and the smooth close to 0. So there I have my line dividing the space, and I can move this around in different directions. Okay, so far so good. One thing I can do is, if instead of v, I take the absolute value of v, it's going to reflect this shape over both the x and the y axes. So let's do that. If I take absolute value of v, but if I increase the edge, now I have a diamond shape. And I'm going to zoom out a little bit. By adjusting these, I can control the angle of the diamond shape. In fact, if I go down here, I'm sort of the opposite of a diamond shape. So I started thinking, well, to control the angle between these, wouldn't it be better to use my angle input? So I'm going to use my angle input. I'm going to name that theta, and I'll just label that angle. And so I'm going to make another variable v2 equals vec2, and I'm going to use this angle. Now, to use the angle input and create it into a vector, I use cosine of theta, comma, sine of theta. And over here, instead of v1, I'm going to put in v2. And now I can rotate this around like that. And not only that, I can type in 30 degrees or 60 degrees and get a shape like that. All right, I'm going to convert the smooth step function into a variable via R, and I already used S, so I'm going to use S1 equals smooth step N. I want to save this diamond shape, so I'm going to add an equation and copy this and paste it down here. And that way I'll have that diamond shape saved. I'm going to try a rectangle, I think, next. And since I'm not using this V1 anymore, I'm just going to delete that. I'm going to create a new variable, var ax, which is equal to the absolute value of v dot x. And then put an ax over here so that I can see what it looks like. Okay, so that looks like that. It's increasing in both directions. And if I put ax into my step function and put S1 over here so I can see what it looks like, it just creates a vertical line. All right, now I'm going to take and do the same thing with y. So I'm going to do a variable ay equals absolute value of v dot y. And if I put ay in here, okay, I get a horizontal line. Now I want to get a square, so I'm going to put in another variable, var m1, which is equal to the max of ax and ay. And I'm going to put m1 into my step function. And I'm going to look at m1 just to see what that looks like. So m1 looks like that. So I'm going to put that into my step function and take a look at that. So s1 looks like that. And I can change the size of it with the edge slider. Now it'd be nice to make this into a rectangle. So since I'm not using x1 or y1 anymore, I'm going to use those. In variable ax, I'm going to multiply the absolute value of v dot x by x1. And in variable ay, I'm going to multiply the absolute value of v dot y by y1. So now I can control the shape of the rectangle with these two sliders. So I want to save that shape, so I'm going to add another equation. I'm going to copy this and paste it down here. And so I'll have my rectangle saved down there. I'm going to go back to this formula and look at D1 again, my diamond. The next thing I want to try to do is to make a hexagon, and this is pretty close to that. If I could chop off the two edges of this diamond shape, I could have a hexagon with the flats aligned vertically. So I'm going to try to do that. In my max function, I'm going to put in, instead of ay, I'm going to put in D1. And I'm going to look at M1 over here. When I set the x value all the way up to 1, I have a nice hexagon shape. If I look at my S1 function now, there's my hexagon shape. Nice hexagon with vertically aligned flats. I like that one, so I'm going to create a new equation and save that down here. Now I want to make a hexagon with flats aligned the other way. So I'm going to change this to 30 degrees. And in this case, I want to cut off the top and the bottom of the diamond shape instead of the other side. So in my max function, instead of ax, I'm going to change it to ay. Okay, so the top and the bottom are cut off. So this is a hexagon with flats aligned horizontally. I'm going to copy that and add another equation and paste it down here. Now I have a hexagon. So I'm Okay, that was pretty cool. So I'm going to do a, set this 45 degrees. I'm going to use a max of AX and AY, and I've got an octagon. I can control the edges with this. I like that. I'm going to add another equation, copy that, paste it down here. I've got my octagon shape. So I've got a diamond, I've got a rectangle, I've got a hexagon going one way, I've got a hexagon oriented the other way, and I've got an octagon. Now I'm going to try to make a pentagon, and my idea is that I'll have one angle up here and then another angle on the bottom, and then I'll lop off the bottom with a flat edge. So to do that, I'm going to add a second angle input. I'll call it PH for phi, and I'll label that angle 2. So this is my second angle. Just set that up to a small value for now. And I'm going to copy my V2 vector, which was for my angle input, and paste it here. And I'm going to change it to V3, and I'm going to change it from TH to PH here and here. And then I'm going to create another dot product, and so instead of variable dot d1, I'm going to copy that and paste it over here right next to it, and I'm going to call that one d2, and that's going to use vector v3. And I want to look at, and then I'm going to change it, the max function, instead of AXAY and D1, we're just going to have D1 and D2 in there. And then I'm going to look at that max function because I want to see what it's doing. M1. So there's that. And if I swing this around, yeah, I can get different angles. Like that. I make a kite. Okay, and now I need to lop off the bottom part, and I did that before, and I remember in my max function I need to put in a minus v dot y. Good, and then I can now look at S1 again. Now I need to figure out what this angle is, and so I could either look it up or know that if I divide this into triangles, I'll have 1, 2, 3 triangles. Each one is 180 degrees, so that's 180, 360, 540 degrees, and then divide that 540 degrees by my 5 angles, and I get 108 degrees per angle, and I know that this one is half of that, so that should be 54. Now this angle is 90. To get 108, I would have to add 18 to that, and I think what I need to do here is subtract 18 from 360, and so 360 minus 18 is 342, and that looks like a pretty good pentagon. So there's my pentagon. Now I could make this, if I bring this one up, I've got a house, or is it an arrow? If I bring this one around, make it more pointed, I could have almost an arrow shape, sort of an arrow. And I could make a little tent or a door, or different shapes like that. There's sort of a tent. So you can make a few different shapes with this setup and modify the pentagon. I can't move my Y. I don't know if that's useful. I could add the Y1 value to it, just in case that is a useful thing to do. So I can adjust the Y1 value to change the shape of this. Oh, there, I can make a gemstone. Okay, I like that. I'm going to add another equation and copy and paste that one down here. One last thing, if I wanted to make a repeating pattern of my shape, I can do that. So I'm just going to change this from a V to a V0 and then create a new variable V equals fraction of V0 minus 0.5. Just center it, and I think that should do it. I reversed my direction of the RY, so the shapes are over in the upper right quadrant now. There are my repeating shapes, and I could get them if I make them overlap a little bit, or I can add more smoothing to it, decrease the size, and maximize my smoothing, bring up the edge. And possibly add a gradient map to this. And drag the gradient on top of the pattern. So they're all in one layer. Like that. Alright, that's all the shapes I'm going to do. But I think once you do a few shapes, it gets a little easier, and it's kind of fun to try to figure out different shapes that you can make using these methods. So I'm using the dot product to make angled or straight lines, and you can use the absolute value function to mirror that across one or both of the axes, and then using the max function to combine the shapes into a single shape. And the smoothstepn function creates the final shape, or the outline of the shape, from the sort of vector shape that you've got. Let me know if you have any comments or questions, and thanks for watching.